Hey everybody, I'm just going to finish up the quick part of the video and then move on to 6.1 in pre-cal. So we did talk about these functions, and now the part you may or may not have seen is about these other trig functions, which sometimes are undefined. So it's undefined if it's like a 1 divided by 0, or like this is 1 over sine. So that's 1 over 0 also. Those are undefined. Now, I do want to graph these a little bit, even though the whole purpose is not to graph it, just so you see how it's all related, because everything is really connected in trig. So first off, when we go to graph trig, first thing is do make sure you're in radian mode, not in degree mode. And let's just take it simple and say sine of x. Okay, so there it is. It's very wavy. It continues between -1 and 1. Later on, there will be all these questions regarding domain, which is all reals, range, which is -1 to 1, and other things like phase shift, like if you move it left or right. In this case, I'm moving it right by pi halves. It would look like that. You can have a number in front to stretch it. Like if I put 2 here, it stretches it extra tall. So now it goes from -2 to 2, and so forth. You can also have your vertical translation like +1 or whatever. But the whole point is it's going to be very wavy. Now, once we did the +1, it's now going from -1 to 3. And you'd have your imaginary middle line around like y equal 1, because then it's 2 up and 2 down. So you use your vertical shift, which is the +1, and that's where you'd go up and down the same amount. Now that's getting a little bit further into 6.1. The main thing I wanted to talk about was how sine is related to a couple of different functions. So sine and cosecant are related. S relates to the c. And so that looks like this. Now, what you notice is the max of the sine equals the minimum of the cosecant over and over again. And the minimum matches their maximum. So it would go like this. Now it does have a many of the vertical asymptotes. The main one is like 0, and then there's also one, and it kind of looks like 3, but it's not. It's actually pi. So this is a case where you might want to, you may want to change your table settings. Go to your table, go to your settings. You might want to start at 0 and go by pi halves. So pi divided by 2. And then you can see it goes between 0, 1, and -1. So these are just like special decimals, but this one's pi halves, which is about 1.57. This is pi, which is about 3.14. This is 3 pi over 2, and this is 2 pi. And it would just continue. Now, that's for sine. Now, when we go over to cosecant, it says hashtag U or hashtag UN for undefined. That's where your vertical asymptotes are. So you have an asymptote at 0, an asymptote at pi, and at 2 pi. The other function that has asymptote at the exact same spot, let's see, that was cosecant. It'd be cotangent, if I remember right. Whoops, I didn't push cotangent x. Cotangent x. So those look wavy, but it does have the same asymptote still. I'm going to take out the cosine, the sine. Just for the moment, take this out. Trying to disable that. There. Okay. So that's my cosecant. And then we were saying if you do cotangent of x, you're going to have the same asymptotes. Oh, I forgot that it removed my settings. So make this 0 by pi halves. So now these are undefined, and so are these. At the 0, the pi, the 2 pi. So I'm under the F3 column, but if I go to the F2 column, it says the same thing. 0 pi, 2 pi. Okay, so those are the ones that are related. So let me write that down. Cosecant and cotangent. Cosecant, cotangent have the same asymptotes. It's the vertical asymptotes. There's no horizontal. And so basically, if it's undefined for cosecant, it's also going to be undefined for cotangent. And if you want to check that, we're saying 1 over tangent. Well, we didn't do tangent yet. But if you do cosine over sine, that's negative 1 over 0, which is also undefined. So basically, you're going to see a lot of spots where these are either going to be zeros or undefined. Because when you do x over... when we do... Oh, I wrote this wrong. If you do y over x, that's going to be 0 over 1, which is 0. And same thing for this one. And for this one, it'd be the 0 over negative 1. No, I'm doing that wrong. Negative 1 over 0, which is also not defined. So these not defineds match up at pi halves and 3 pi halves. Now, before I just try to fill out the whole thing, I want to show you all more about how some of these are related. So, tangent is the red one, which goes forward or is increasing. Tan is increasing, and cotan is decreasing. Cotan is the black one, that's decreasing. and tan is increasing. That's the red one. I know this is a lot to take in, but these are a lot of things you're going to learn as the next, chapters go by. Let's see what else. I can also tell you that if I disable cotangent and I make sine available again, sine and tangent have the same x-intercepts. Sine and tan have the same x-intercepts. Now, a lot of this is going to be in your notes as well. I'm just trying to describe it right here. Okay, so y'all continue working on this part, because I don't want to just give you everything, but it's going to be pretty easy for you to figure out. Especially for those parts, for where it's either 0, 90, 180, or 270. But now for this part, these are your others that have exact values. It says answer key, but it's not, obviously. What you're going to do is use your unit circle and figure out that at 30, it was 1/2, because the ordered pair was square root of 3 over 2, comma 1/2. So that's that one. And now, again, how these are related is if you flip a half, you get 2. So this is 1 over sine. Now this one, cosine, is the x value. And how that relates is it'd be 2 over square root of 3. But you're going to want to rationalize it. It means put the square root symbol on top and bottom. So you have 2 square root of 3 over 3. And then on tangent, you have square root of 3 over 3, which was originally 1 over square root of 3. Now when you flip that, you just get square root of 3. That's the easiest way to do it. The harder way to do it is, okay, well, you told me you have square root of 3 over 3, so let's flip it. So we have 3 over square root of 3 and multiply by that. So you get 3 square root of 3 over 3, which cancels. And so that's why those end up being the same thing. Now on the 30s and 60s are just going to be reversed. So where this was square root of 3 over 2, this one is. Where this is 1/2, this is. Now for tangent, that's the y over x. And so your 2's actually cancel, and so it's square root of 3 over 1, which is just square root of 3. And then this one would be like what we got here, 2 square root of 3 over 3. And then notice we had this square root of 3 over 1, which is 1 over square root of 3. And when we rationalize it, we got what was in the key part, where it's square root of 3 over 3. So those are a few of them. Now the other one I'm going to do was just these. So y'all fill out the rest of that, and that'll be good for the end of the unit circle video. I'll upload that, and then I'll start on the 6-1 on the next video. Hope that helps. Have a good one.